Welcome to this webinar. What is the role of digital twins in achieving our sustainability goals? I am Thomas Lane, the technical editor of Building Magazine. Digital twins present a hugely powerful opportunity to help the construction industry to better understand the energy efficiency of a building and its performance. As the need for our buildings to be net zero becomes ever closer, our panel will explore the role that digital twins can have in achieving our sustainability goals. Today, we will explore what opportunities are available to the industry through digital twins and how these can help reduce carbon emissions. To discuss the potential digital twins, I'm joined by a panel of 4 speakers. Catherine Donald, who is the digital design leader at Max Fordham. Peter El-Haj, who is a program lead for the National Digital Twin Program. Alex Balisat, who is a senior research engineer at the Centre for Modelling and Simulation. And finally, Neil Thompson, the digital construction director at Atkins. So each of our speakers will talk for about up to 10 minutes approximately. So in terms of what they're going to cover, Catherine will go first and talk about how digital twins can help reduce energy consumption in buildings to actually achieve low energy buildings in practice. Peter will give an update on the National Digital Twin Programme with a focus on the Climate Resilience Demonstrator Project, which is a tangible example of how connected digital twins can help improve resilience and sustainability of infrastructure systems. Alex will cover the anatomy of a digital twin in detail and how the concept can be used to overcome some of the challenges faced in the sector. And finally, Neil will introduce a project he's leading for the Construction Leadership Council called the Apollo Protocol. This is an agreement between the built environment and the manufacturing sector, focusing on interoperability and enabling the built environment to be a platform for manufacturing to understand the whole life performance of products. So we'll do the presentations, and there will be time at the end, I hope, for some questions and answers. So if there's anything you really want to ask our panel, you type it into your into the box, and we'll endeavour to answer as many of these as possible. So anyway, without further ado, I'm going to hand over to Catherine for her presentation. So thanks very much, Catherine.
Thanks, Thomas. Just waiting for it to go into presentation mode, I think. There we go. Can you see my screen?
Yeah, I can. If you could maximize it so we just see the presentation. That's brilliant. You're good to go.
Perfect. Thank you very much, Tom. So as Tom said, I'm Catherine Donald. I work with Max Fordham, who are building services engineers. I've been in the industry for over 10 years now. So started out as a building services engineer, and I've transitioned to my new role of digital design leader, where I'm responsible for our digital transformation and our building performance modeling team. As Tom mentioned, I'm going to be discussing how digital twins can aid. Sorry, I just lost my thing. How digital twins can aid our reduction in energy in operation of buildings. Sorry, slide's not moving on. There we go. So just to set some context as to where buildings sit in relation to the UK's total carbon emissions, I'm sure most people are aware that buildings account for almost a third of our total carbon emissions every year, which is a significant amount, particularly when we're in this climate emergency that everybody's discussing, and we seriously need to make huge improvements to be able to address the issues about our carbon emissions and the impact it's having on the planet. So as an industry, we're striving towards low energy design in an attempt to sort of understand how our design decisions make impact on the energy consumption and the carbon emissions from our buildings. We model our buildings to understand what the strategies, the best optimum strategies are for the buildings that we're designing. And now there's various ways of modeling the energy predictions, but more often than not, people are using, because it's law, to produce energy performance certificates, or modeling that using that standardized approach. However, you can see that having a good EPC does not equate to a low energy design in practice. From this graph from the Better Buildings Partnership, A Tale of Two Buildings report, you can quite clearly see that actually it pretty much doesn't correlate to how much energy the building is going to be using, what the result of the EPC is. And there's many reasons for this, but buildings are really complex. Each one is essentially a prototype when you compare it to mass manufactured products. And there's loads of reasons for this. The main ones being things like the build quality, the quality of the commissioning of the building services, and then most of them related to the operation of the building. Buildings have so many different components and pieces of equipment that require maintenance over the life cycle of the building. It's really hard for designers to predict how buildings are going to be used, and also how they're going to change through their life cycle of 30, 40, 50 years. There's also, sort of more external factors about weather changes. It's quite clear that climate change is having a massive impact on how our buildings operate, and also, external factors such as the carbon intensity of the grid. A design solution from 10 years ago is not necessarily the optimum solution for that building now. I mean, one other aspect is we previously never actually looked at how our buildings were operating after they were built, as long as they were comfortable for the people in using the building, and they weren't using an excess amount of energy and therefore costly to run. We were not really going back. This is a couple of decades ago, not going back and checking how they were performing. But as people have become more aware of the disparity in the energy use between what the building's designed to do and what it actually operates at, people are starting to go back, like ourselves, to look at the buildings that we're designing to understand how they're performing, and looking at how we can get them to perform as expected. As this demand has increased, the technology that's available has become better, and it allows us to extract the data in a usable format and allows us to fine tune the building. As you can see from the graph, though, it takes a while for people to digest that information and to then tweak how the building's controlled and performing, to really optimize that building. Not only that, it also needs to be a continual exercise. As soon as people stop looking at where the energy is being used, and sensors become uncalibrated, and the optimum control strategies come out, slowly sort of slip out of alignment with how the building's being used, that energy use then starts to increase again. So this is kind of where digital twins and digital platforms can come into their own. The amount of data that we now have available in a building is increasing rapidly. You just have to look at the edge buildings that are being developed and constructed around the world, which have tens of thousands, of sensors throughout them. As humans, we struggle to be able to digest that amount of data. And that is where the computers, having digital platforms, can really help us to basically take that element of it away from us and to be able to digest that data itself. Digital twins can then monitor for anomalies, operation of components, sensors out of alignment, out of range, energy use in certain areas of the building or in individual pieces of equipment. they can, analyze for that and then flag that to the users. One area where I think is really exciting for digital twins, though, is the optimization of the operation of the building, and being able to actually adapt the control strategy to reflect how the building's being used and the external factors that have a impact on the energy itself. So if we take, the design solutions, passive design solutions that as designers we try to focus on initially to try and maximize or minimize the energy demand in the building. This is where digital twins can help us to refine those controls around that. So if we take a space like this, which has a lot of thermal mass, exposed thermal mass, with concrete soffit, concrete walls, we want to use in this space, we want to try and free cool or nighttime cool this space, use that thermal mass to store that cooth. Digital twins can allow or can optimize the level of cooling that or free cooling that we introduce to this space using weather predictions, looking at how cold the evening's going to be when you start introducing that the natural ventilation, the use patterns, whether it's an office building or a retail type space like this. There'll be some understanding over time of how people are going to use the building and the heat gains, etc. And all of this has to be within the limits of what the comfort conditions are. So there's a lot of external pressures and variants that need to be considered trying to optimize the free cooling in a space like this. And sort of linked to that, I mentioned about use patterns. It's hard to predict as designers how a building's going to be used, but people are creatures of habit. So over time, there's an opportunity for us to learn, or for the digital twin to learn how the building is used, and to then optimize the control systems to suit that. So it's avoiding overheating or cooling a space, having spaces that are lit overnight when you know that there's no one in the space. They can make intelligent decisions about turning systems on and off or controlling them to suit. I mentioned that buildings are complex, and they're only getting more complex with all of the technology that we introduce to try and minimize the energy use and therefore the impact on the planet that our buildings are having. The problem with that, though, is that they can actually end up using more energy if they're not controlled and maintained appropriately for the building type. Digital twins give us an opportunity to assess how the building is performing and to try and maximize the carbon and energy savings. In this type of situation where we've got electrical storage and electrical heating, we've got an opportunity to use the predictions of how carbon intense the electrical grid is, use that forecast to predict when we can, or assess when the building can use the electrical grid at its lowest point of carbon intensity, and then maximize the use of the PV generated electricity and the stored electricity to minimize the overall carbon intensity of that building itself. Through using digital twins to monitor and collate all of this data that buildings are producing, it also gives us an opportunity to better understand how buildings are being used on a more global scale. The more data that we extract from these buildings, we can then use the analytics that are produced from those to then better inform our energy models during the design stages, which allows us to then better predict what systems and strategies are better for the buildings in terms of minimizing their energy and carbon use, carbon emissions. That's my presentation. I hope that was interesting for everybody.
Great. Well, thanks very much indeed, Catherine. Quick question for you before we move on.
Sure.
So I mean, obviously there's a lot of benefits to digital twins, but to what extent are you using digital twins in your projects?
Interesting question. It depends on the scale of the digital twin. There's a few projects where clients are really keen to take advantage of this, the technology that's now available. It's a slow uptake. It really depends on the client's ambitions. We're seeing it more now with net zero carbon being a big driver, and them starting to understand the impact that digital twins can have. So we've not got any buildings that are actually built yet that are using a digital twin, but there are a few that aren't far away. So I think in the next couple of years we'll see a much bigger uptake once people see the sort of case studies, more case studies become available.
Great, that's great. Sounds very encouraging. Well, thanks very much indeed, Catherine. So I'm going to hand over now to our next speaker, who is Peter El-Haj, who is a program lead for the National Digital Twin Programme. So over to you, Peter.
Thanks very much, Thomas. Just going to go full screen. Okay, thank you. Thanks very much for the invitation to share with you about the National Digital Twin Programme. So I'm going to give a quick update and context for the National Digital Twin Programme. Then I'm going to talk in a bit more detail about our CREDO, or Climate Resilience Demonstrator project, which is intended to be a tangible example of the benefits of connected digital twins in the context of improving infrastructure systems resilience. To start things off and set the scene, just going to give the starting point of the National Digital Twin Programme. So in 2017, the National Infrastructure Commission published a report called Data for the Public Good, which effectively put the vision for a national digital twin as an ecosystem of connected digital twins, and put in 3 recommendations for government around delivering an information management framework, which is the common rules and resources needed to enable data sharing and information sharing across organizations or across digital twins, and to enable a national digital twin as the ecosystem, and to align industry, government, and academia through the Digital Framework Task Group. So this is effectively the mission of the National Digital Twin Programme. The program has been established by Treasury at CDBB, so that is the Centre for Digital Build Britain. Since then, it has been endorsed as part of the National Infrastructure Strategy, the UK Innovation Strategy, the National Data Strategy, and many other government documents. I just want to highlight the in the title, the Socio-Technical Change Program. So we see it as a transformation or a change program where the social aspects of things, so the people aspects of things, including government, governance, commercial, legal, ethics, is as important as creating the technical foundation or the technical resources to enable an ecosystem of digital twins. One of the first publication on the program was the Gemini Principles, and these are the guiding principles or value for the program, because the program was seen as potentially multi-decades program. It felt that if a key foundational thing to start from is a core set of of values or principles. So these are the Gemini Principles, which are listed against 3 headings. So purpose, trust, and function. Now, when it comes to the approach of delivering the information management framework and the National Digital Twin Programme, so I'm going to present the core of the approach represented in our 3 core projects for this year. As a first component, we have the information management framework. So this is the common resources, standards, guidance to enable effective information management across organizational and sectoral boundaries. This is specialist-led. It can be seen as a top-down standards. And we've, for each part of the program, we have a strapline or motto. So for this one is collaborate on the rules, compete on the game. The idea is to for everyone to come together to collaborate, to create common rules for data sharing in a way that it is it's not expensive to create the connection, and it's not expensive to maintain the connection across different information systems. This is balanced by a community-led, which is by the community effectively called the Digital Twin Hub. So the Digital Twin Hub is a community of digital twins practitioners, owners, operators, supply chain. The purpose of it is to learn by doing, progress by sharing. What this practically means is just to collaborate on creating the best practice around digital twins, case studies, put in resources that help organization articulate a business case and start their journey on digital twins. And finally, our third key project for this year, and with the focus of the slides, is CREDO, which is an acronym for Climate Resilience Demonstrator, and is a tangible example of the National Digital Twin Program. Just wanted to highlight that you can learn a lot more about the information management framework if you're interested through the DT Hub. So it's digitaltwinhub.co.uk, and you can find plenty of information around the IMF. Here is just a snapshot from the requirements for an integration architecture, which is set out to be distributed, federated resource. And then the Digital Twin Hub itself is a community of more than 2,900 members now from more than 60 countries, with many of open and accessible and free resources to access. Before I jump into the CREDO presentation, I just wanted to highlight this recent publication from the Infrastructure and Projects Authority and their Transforming Infrastructure Performance Roadmap 2030. I just wanted to highlight the built environment model, and in particular the digital twins. I hope this is coming through the shared slides. But what the core or the essence of this model is, the natural environment and the built environment are formed of many systems in different life cycles, and digital twins enable us to get data or get information out of these systems and their different life cycle, and then to intervene in the physical world, which is the combination of a built and natural environment, and it's all guided by societal outcomes. So here you can see the UN Sustainable Development Goals on the top, and just to say the NDTP is the National Digital Twin Program is very aligned to this model, and it's very, of course, relevant to the topic of the panel today. So going to CREDO. So CREDO is in the context of the climate emergency, which we are seeing all around us, with many flooding events that unfortunately cost lives. One example over summer would be in Germany, similar in China, and this is the where CREDO's motivation came from. So it is all about helping better respond and better plan for climate emergencies, in the case of extreme climate events. So the purpose from CREDO is to help address climate change and climate adaptation in particular. So climate change is a systemic challenge, so it hits all systems. It doesn't hit one sector or on one region. So it's a systemic change that demands a systems-based solution. And the way to enable addressing it from a systems perspective is to enable the data sharing across the different actors within the system. So this is the purpose of CREDO is to provide a tangible example of how cross-organizational information sharing can help improve infrastructure systems resilience. Another purpose of CREDO is to apply the information management framework, which I mentioned earlier, as a key part of the National Digital Twin Program, and to show how a common way to integrate data across organizations is beneficial to both who are making the decisions, but also for broader benefits for the community where the systems apply, the infrastructure systems apply. The CREDO project itself is described as a climate change adaptation digital twin. it is a collaboration with many partners. I'll have a slide on that at the end, but just wanted to highlight that it is based on data from Anglian Water, British Telecoms, and UK Power Network. So 3 utilities that cover same geographical area coming together to share data using the IMF approach. And then the purpose is to enable these 3 utilities to make better interventions on their network in a way to minimize cascading failures and to improve collaboration for climate adaptation. At a high level, the technical architecture for a flooding use case, which is what Credo is starting from on a flooding use case, is to look at for example, climate scenarios, weather scenarios, flood depth, individual asset availability, and then look at the system of systems level outcome and looks at cascading failure of systems. The output from Credo will be a technical visualization and decision support tool for the asset owners. The idea is benefits should be felt by the asset owners who are putting effort into integrating their data across organizations. Of course, an ultimate goal is to have better social outcomes for everyone in the region, but from better resilience, better safety. But also from a knowledge perspective, is to have a scalable and replicable way to connect information across organizations. So who's involved? So it's a big group of collaborators coming together to deliver Credo. The project is funded by UKRI, so UK Research and Innovation, by the Connected Places Catapult, and by the University of Cambridge. And it's we have the 3 utilities I mentioned, and we have a big constituency of research institutions and universities also coming together to enable the integration. We also have domain input by Mott MacDonald, and I'll also touch on Esri and Crocodile Media, who are helping us with 2 communication pieces for COP26, which is coming very quickly now. So the first one is the Credo film, and this is just a sneak peek. It's not published yet, but the idea is to tell a story, not a technical video, but a story about how connected digital twins and cross-organizational information sharing can improve the outcomes, the social outcomes for people, and can hopefully save lives. The second one is the Credo interactive app. Again, this is a public demonstration for COP. The idea is to enable whoever the user of this interactive app to take the role of a resilience planner and to test various scenarios. So a number of options when you are looking with a siloed look or from one organization's look without looking at the impacts on other systems. And then another one is from a connected digital twins look, when you have the ability to analyze the impact of your decision on other systems within the infrastructure systems. So this is also being developed with Esri and also will be launched for COP. Finally, to mention that we are launching both the film and the interactive app at an event, a Credo webinar on the 2nd of November. So this is intended to bring together all of the parties collaborating on Credo and to share the film, the interactive app, but also to present the next steps on the project, because the project doesn't end with COP. There's the entire technical development with the 3 asset owners that is continuing till next year. So, and this is from NDTP Credo side of things.
Great. Well, thanks very much indeed, Peter, for your presentation. It sounds really interesting, and I wish you all the best of the project. I think we're going to move on now to our next speaker, actually. So it's Alex Balisat, Senior Research Engineer for the Centre for Modelling and Simulation. It's over to you. Thanks very much.
Thank you very much. Hopefully you can all see a presentation. Excellent. So yes, good afternoon. I'm Alex Balisat. I'm a Senior Research Engineer at the Centre for Modelling and Simulation. For those of you who don't know who we are a not-for-profit research technology organisation based in Bristol, and we work across a broad range of industries, including construction, automotive, transport, energy, and aerospace, to help organisations implement digital technologies. So for the next sort of 7 or 8 minutes, I'm going to be talking more about the anatomy of a digital twin and more on the theoretical side, because we've had 2 great presentations which have talked a lot about the implementations of them with some very interesting examples. I'm hoping to give you more of a flavour of what actually is a digital twin and the potential power of them. Okay, so the construction industry faces quite an interesting set of almost unique challenges. There are a wide range of problems as well as potential solutions to solving those to head towards zero carbon. And within that, there is no golden path. It's not like there is a way which will solve all problems that we just need to get along. There are just so many different ways and problems and challenges we've got to overcome. Alongside this, prototyping new technologies and new solutions to problems can be rather slow, and it can also be very expensive to implement. You think about putting a new system into a building or just designing a new building from scratch. It takes potentially many years. It can cost hundreds of thousands, if not millions of pounds. And even if you do that, it potentially takes an awfully long time to actually see the effects. So how can we cheaply and efficiently move towards a zero carbon construction industry? And this really is where digital twins come in. So what is a digital twin? It's a term that's bandied around an awful lot, but I always feel like it's never very well explained as to what it actually is and how it can enable us to achieve our goals. So to my mind, and this is a model that we've applied across a wide range of projects and a wide range of industries, a digital twin fundamentally consists of 3 different processes which all come together to complement each other. So we have data, which is the physical data that goes on that you can use to calibrate your models. You've got the physical modeling, which is actually being able to make predictions, and you've got the expert knowledge. So the data is always the fundamental underpinning of this. It allows us to look back on the history of a system, and it's very important to note that data only ever allows you to look backwards. If you try and build forward models of data, you have the implicit assumption that what will happen in the future has happened in the past. Now, that's not always a good assumption, especially in a changing world. And as Peter just alluded to, the climate emergency that's going on, things are changing rapidly, and things are happening which you might not have expected to happen when buildings were built, certainly with older buildings which may have been built 20, 30 plus years ago. But the data allows us to effectively calibrate our model and apply data modeling techniques to try and understand what has happened in the past. Complementing this is physical modeling. Now, physical modeling is the idea of taking a set of equations which in some way describes the physical world. Now, this could be anything from simple heat models through to more complicated, say, fluid dynamics models that would allow us to understand how heat or fluids move through a building. And this allows us to make forward predictions about how the system will behave in the future. Now, the crux with this, and this is the really important point, is that physical modeling allows us to make predictions about things that have not yet happened. So if we don't have the data for it, we can predict what would happen to either just give us pure insight into that from the outcome of the modeling, or allow us to generate data which we don't have to then say feed into our data analysis systems to predict how are they going to react, what is the outcome of that going to look like. And underpinning the whole thing is expert knowledge. And the expert knowledge incorporates experience from other systems and from new technologies. At the end of the day, a computer is fundamentally stupid. It will only do what it's told. So if we don't have the experience and the knowledge that we can feed into the digital twin and into the system, we are never going to be able to allow it to make good predictions and for us to be able to test technologies. Which leads us on to the next thing, scalable digital twins. Now, in the modern world, computing is fundamentally cheap. You can go to an organization like Amazon Web Services or Google Cloud, and you can literally click on a computer that you want, and it can be enormous. It can have massive amounts of memory, huge amounts of storage and hard disks, a ton of processors. This allows us to evaluate many potential solutions in parallel. So we are now in a world where, rather than going through traditional waterfall approaches, where you down select solutions very quickly and just take one to prototyping, in a digital world, using modern digital techniques combined with computing and some clever maths, we can take a multitude of potential solutions to get forward together and then choose the best one after taking them all through detailed development and design. So going away from this idea of having single point solutions, we can test many out to find the best. And then when you've found the best, we can then start to incorporate uncertainty. And this is really important in a modern, changing world where something that you've designed for may not happen again, or things might change. So we can understand how things will perform in the real world where these variations in conditions will happen and uncertainty arises. So rather than just, say, designing a building for what happens on a sunny day or just on a rainy day, we can take into account a whole range of potential weather conditions or performance characteristics that may occur and understand what is the best solution overall, moving away from this idea of having a single point solution. And this moves us towards the idea of robust design. So there are many designs that you could come up with which may be unstable. They may be brilliant and perfect in one set of ideal conditions, but if you move away from that tiny perfect point at which these things occur, then the solution may not be as good. Your performance will be worse. So by enabling us to test out a multitude of possible scenarios in which our digital twins and our solutions will exist and behave, we can actually move this towards being able to understand in a wider, bigger context how things will perform. And this sort of leads us on as well to the idea that digital twins are not just about single point solutions and models, as people have alluded to in the past, that these are more about an ecosystem. So how do buildings not just enact on their own, but act together? And we have the modern computing and data technologies that allow us to easily and quickly estimate what this is going to look like. And we can go on the move, we can go quickly, we can change how we're acting and how we're performing, and allow this to actually give us a bigger holistic picture, moving away from these single point solutions. There is no reason why we couldn't, if there was the will, build digital twins of an entire city, which consisted of digital twins of individual buildings, which consisted of digital twins of individual rooms, and end up with one giant ecosystem that all works together. The technology, the compute power, and the infrastructure is there for us to do it. I think it's now just more of an industrial change and being able to move towards doing this in practice. That is a big challenge. And also, it's a huge opportunity, a huge opportunity for the construction industry here to move towards a digital system of design and construction and manufacturing and long-term maintenance. So I've kept it hopefully quite short and brief to allow some more time for questions. So thank you for listening. And just to summarize, my thesis in a nutshell is this: developing, prototyping, and validating novel technologies and solutions for a zero carbon construction industry is prohibitively time consuming and expensive. Digital twins as a technology provide the platform to learn from the history of a building, incorporate expert knowledge from other buildings, and predict how different technologies will impact its future performance across a wide range of scenarios. Digital twins are themselves a fast, cheap methodology that will enable the journey towards zero carbon. They are not the solution, but they are a very powerful tool to help us along the way. Thank you for listening.
Great, well, thanks very much indeed, Alex, for that. It's really interesting. I've got a very basic question for you. I mean, I could see, the very great explanation of how, a digital twin works, bringing those three elements together. But I mean, if I'm someone in the industry, I'm working, I don't know, in BIM or something like that. How do I do it? Is there software I can buy which I can use to create a digital twin, or is it bolted in, implicit in the BIM model? What does it look like?
It's a way. It's about understanding your requirements, your goals, and your constraints, and then either taking an existing platform, and there are a huge number out there, or you can go to an organization like say ourselves, and somebody who's got expertise in it, and they can point you in the direction of the right platform, the right tools. What are you trying to model? Are you more focused on forward predictions? Are you more focused on historic data? Have you got a huge body of expertise that you'd like to wrap into a knowledge base that you'd like people to be able to use and access across an organization? And this, I think, is the thing with digital twins. They're bandied around as this golden hammer with which you can go and hit every problem. But very rarely is it actually explained what they are. And digital twins are different things to different people. So I'd say the best thing, if you're not sure what this is, go do some research, come talk to us or another organization, and we can help guide you along this process, because there is not a golden bullet to digital twins. It doesn't exist.
Right, brilliant. Well, thanks very much for that. So we're now going to move on to our last speaker, Neil Thompson, who's the Digital Construction Director at Atkins. So Neil, over to you.
Hello everyone, you can hear me now. Hello everyone, and to check, you can see my screen?
That's looking good, yeah.
Awesome. So I'll crack on. So how are we going to use digital twins to drive sustainable culture change? And it's an important thing for us to understand here. And for me, digital twins are essentially the extensibility of the internet. The internet's gone through different evolutions. So in its what was known as the first platform was essentially connecting mainframe computers. Second platform was essentially connecting the personal computer to desktop computer. The third platform was when we threw mobile phones into the mix and we connected mobile phones to the internet. And we're entering what I'm calling the fourth platform, where we've seen it emerge with the Internet of Things and Industry 4.0, but that's only just the beginning. What I'm talking about in terms of the fourth platform of the internet is essentially the connection of everything else. All the previous ones are sort of the ratcheting up of different technologies that were suitable at the time, but we've reached a tipping point with the internet where there isn't really any barriers to connecting absolutely everything. And the reason why we can do that is we've reached say a tipping point, but a point with the economics of technology. There's the cost of transistors as a function of computing power and storage has reached such a low level that these things are really small and cheap and can be, these phones are, in the hands of most people on the planet. And the cost of connectivity of the internet has reached a very low price as well. And those things coming together means that we can do things with data. So the cost of implementing artificial intelligence has hit the floor. I mean, most of us can go and learn a course for free and apply some low levels of artificial intelligence on Google Clouds this afternoon if we wanted to at no cost. And as a proxy of being able to connect things to the internet, and I'm using robotics here, is the cost of robotics compared to the price of labor has reached a point where we can implement robotics at a large scale. So all these things come together, and they're the sort of the technology phases. We've also got a cultural dimension to this as well. So back to our mainframes and personal computers through into connecting the middle classes into connecting everybody else to the internet. And we know today, I mean, look at what the outcome of the pandemic and how the internet essentially saved our skin. It's a systematically important part of society, but we're only at the beginning of that journey. If the first 20 years of the internet was about essentially connecting documentation, the second 20 years was about enabling forms of services, the disruption of the entertainment industry and print media and what have you. The third set of 20 years for the internet is the internet of the built-in environment. And this is important context, because when we think about behaviors of people on the internet, something interesting has happened. And this is from a consumer perspective, is people have gone from searching the cheapest thing to searching for the best thing. They've moved from, just find me whatever and as cheap as possible to I actually want the best performing thing. Now, if we scale that culture up into industry, and we know, and we think about what Catherine was saying about buildings and their performance and how they don't quite perform when you switch them on for the first time. What happens if we can utilize the culture that's been enabled from a consumer perspective on the internet into industry, where people are searching based on performance for industrial level issues, not just trying to buy stuff off Amazon. So this is here today. This isn't blue sky thinking. These are cultural shifts that have happened. And if you look at the time frame, that time frame isn't very long, so we could make change quite quickly. So moving sort of procurement culture from the lowest common denominator, cheapest price, to what is the best performance is key, and the internet has enabled that to happen for consumer products, and it should happen to enable us to make better decisions about infrastructure. So in terms of today, I wanted to give you a quick example. So Atkins, we work with Cardiff University, and we've been implementing I say a tool. So this is a point that I wanted to make. So as much as the browser for the internet is just a tool, the browser almost oversimplifies the massive complexity that happens in the background in order for that user experience to be smooth and for you to be able to do your internet banking or watch Spotify and what have you. And the key thing here is, when we're looking at digital twin solutions, you probably only ever see them in their browser form. You'll see them as some pretty pictures and graphs. What's happening in the background, and the key part of the value adding piece, you know, the value adding piece for you as a user of the internet is the browser, but you've got to think of all the business change and technological change has happened in the background in order to it to work. So you know, the work that we do when we're implementing these across a series of different types of infrastructure, you know, first steps is around governance and ethics of data. We have to ingest data, and we have to make sure that data is used. You know, if you're ingesting data, that data is owned by someone somewhere, and making sure that that data is collected in a way that is ethical. And then it has to be safe by design. I mean, I don't have to go too far into telling you about the cyber risks of connecting critical national infrastructure to the internet. And then, you know, about data management, and, you know, without data management, all of the next stuff in that list is not going to happen. So integrating sensor information, no matter what the lag is, you know, 10 seconds to 3 days, or in the milliseconds in some cases. But with all those coming together, and you have to do those, it enables you to do the smart stuff. So to apply machine learning, to understand patterns. What I don't like the use is, you know, as was said in the previous talk, you know, these things kind of fall over when you're trying to predict the future. So when people talk about predictive technologies, machine learning isn't necessarily about creating the prediction. It's about saying, it's about recognizing patterns and enabling you to see patterns that you might not have seen, because they're multi-dimensional problems, and we're only really good at seeing 2 or 3D at best. And then on top of that is then the bit that we see, or the bit that's generally sold to us, is the visualization of these things, and then from there is the data-driven decision making and the understanding of the behaviors of the performance of the decision that you're trying to make. And this is the stuff that's happening today. I think I'm sort of just saying and reflecting on what's been presented previously, so I don't want to go too much into that, but it's, you know, this stuff is happening today, but there's an important context here. You know, that is in the context of a particular design process for buildings, like building services, for example, or in the example that I gave is about operational information. What can you understand about a building once it's turned on, collecting sensors data, open source data sources, and bringing them together and visualizing them to make you make a better quality decision. What we need to think about is, well, how do we integrate with other design processes? You know, the pumps and the products inside those buildings have their own design process that has nothing to do with building services. Building services design from a buildings perspective, and how can we start enriching that conversation? So I lead a project called the Apollo Protocol. The Apollo Protocol is to build upon the Gemini principles, and it's sort of a fun nod to, you know, it was the Gemini program that was the precursor to the Apollo program for the NASA's mission to the moon. So with the Gemini principles being the base building block for digital twins, we wanted to build a program that was giving a nod to that, hence the name, the Apollo program. And we have a rich collection of stakeholders from, you know, I won't list them all here. I've only got a small amount of time, but you know, want to bring together the best players in terms of the built environment and the manufacturing space to bring about an agreement on how we're going to make our different engineering disciplines interoperable from a design process perspective. Because the problem that we have is we've split the space into 3 spaces. So there's the manufacturing space and all the design stuff that happens in that world. We have the built environment space and all the design frameworks in that space. And in the middle, there's a technology space in terms of you know, our opportunity to connect these things together. And I've touched on sort of the dynamics of technology previously. And we're using the story of a pump as our vehicle for telling this story, because that pump has a design life cycle from a manufacturing perspective, and then the pump has a systemic life cycle from an operational perspective in the built environment. And the simple thing we want to achieve is, in the manufacturing world, they want to make smart, you know, they want to create smart product development life cycles. In the built environment, we want to create systemic and whole life views of the performance of buildings. And at this moment in time, those 2 worlds don't talk to each other. And what we want, and I'll finish on here. What we want to bring about is is what we call the great unification of engineering. So what isn't on here, for example, is the word design, because these design these design processes sit in different places. How can we bring all these different considerations around the life cycle, so the manufacturing, assembly, install, and operations of a pump together? So watch this space. Get in touch if you want to get involved. And there was one last thing, actually, and it's a really important point to make. We have some consequences here that we have to think about, and I'll make this really short. If we think about the implementation of Bitcoin and the amount of energy that is, the energy demand of it, it's an unintended consequences of the application of technology. We have the same thing ahead of us if we're not careful from a digital twin perspective. Just because we can connect everything to the internet doesn't mean that we should. We have to be completely mindful about how we go about doing this. And the other side of the Apollo protocol is to make sure that, for example, we don't accidentally censor everything, just and the waste that will be generated from that from a physical perspective doesn't happen. So I'll leave that there. Thank you for your time, and looking forward to questions.
Great. Well, thanks very much, Alex. I've got a quick question for you before we sort of move on to general questions, and it's a good opportunity to sort of say to anyone out there, if you want a question you want to ask, please ask it now. So a question for Neil really is, I mean, there is a real risk of data overload here, isn't there? Is that a risk, do you think, that it's just going to be submerged by so much data, which, I mean, obviously it's data you need, but data that you don't need, and how you distinguish between those two things?
Well, we've already got loads of data, and we're creating more and more as each day passes. I forget the shape of the curve, but let's assume it's exponential, right? So all the data that will be created over the next month will dwarf that was created in the last year type thing. So yes, you're right. And this is what's key, right? So there's data management, and it's it's a little bit like excuse the way I express this. Librarians are seen as not very interesting people or things to do, but actually they play a very vital role, because it's not just about finding a book, it's about connecting your interest with your knowledge. And it's exactly the same in the data world. The thing that we find is everyone seems to be quite interested in these sexy visual front ends to show how they're going to improve their decision making, but there's an awful lot of hard work behind that in terms of data management, which is key. And that's where all the effort is required, because as you say, we've already got too much information, and we're going to be creating even more of it tomorrow. So data management is critical.
Great, well, thanks. So if I can ask our panelists to put their cameras on, and we've got a few minutes to take some questions. I've got actually a question that's pretty similar to what I just asked Neil, really, which essentially is, for the other people on the panel, is how you actually overcome data management issues when you're getting it from disparate sources. You're getting your data from all over the place, and you want to create a successful digital twin, but you've got to manage all that data in a meaningful way. How do you do that? Anyone want to tackle that, Alex?
Yeah, I think the first thing is a lot of people don't understand what the data they're getting is, and I'd certainly echo what Neil said about there being far too much. You can go by sensors. Let's say a temperature sensor. You can go by a temperature sensor and get it connected to the internet for less than £1. So everybody's reaction is, well, I'm just going to go do it, and I'm going to go buy 1,000 and shove them in a building. Great, but actually understanding what does that mean? What is the use I'm getting out of it is the important thing. And actually, rather than going buying 10,000 sensors, are you better off just going to buy 10 and putting in the 10 crucial points that are actually a measure of what's happening in the building properly? And I'd say with the data management, it's the same sort of idea of, do you need all this data? And more importantly, do you actually understand what it is you're getting? Because certainly in my experience, if you understand what data you're getting, the data management is easy, because you know what to do with it, you know how to store it, you know how to process it. So I think really you should take a step back and just say, well, what am I actually collecting and why? And do I need it? And if you can answer those questions, then the management just flows naturally from that and basically becomes trivial.
Neil.
Yeah, so yes, and there's a professional, data management has been professionalized, and there's the Data Management Association, and they provide lots of frameworks on how about going to do this. So that's a first step. If you're not aware of that, go do that, because the learning and the process is required to understand those things. They've mapped out very well. And I think assuming that you, for example, have understand your target use case and the things that you're looking to achieve with the capability that you're trying to create from a digital twin perspective, once you've got that out the way, is what they call a data catalog. So understanding, you know, draw a box that is the thing that you're trying to solve, and there's going to be inputs and outputs, and you have to be completely clear about your inputs from a data perspective. So as I say, you have to be completely sure about whose data that you're collecting, who it belongs to, because you never know, 10 years down the line, someone might find out that you've been using their data and be wanting royalties against it, for example.
Right. So Peter, I think you wanted to come in as well on this topic.
Yeah, just briefly, it's just to strongly agree with both Neil and Alex on that point. I think Alex's point on being clear about the purpose of your twin and therefore identifying your information requirements or your data requirements, I think is an essential shift in the way we want how digital twins will end up being useful. I think what this also indicates too is the importance of data quality and the approach in which you identify your data requirements. There are lots of progress in this area, as Neil mentioned. And I think in many ways this links to your previous question, Thomas, to Neil, around this emerging complex data landscape, which is very true. And I think what it pushes to is a cultural shift in many ways, from a siloed look at the world really to a shared and collaborative look at the world, where people are less wanting to have control and full visibility on things, and more have trust in what they are getting has been rigorously and was generated with a high quality process in mind. So trust what is outside your control boundaries. And I think this is essential as well in digital twins and ecosystem of digital twins as they as they emerge and they are focused on social outcomes, environmental outcomes, etc.
Right, I see. So we need to be more open, really, don't we? Another question, I'm going to put this on to Catherine, actually. We've got someone asking how digital twins can be applied to existing buildings. She's thinking about retrofit in particular. Do we have the converse problem that there isn't any data in which you can create a digital twin, or do you have to create that data set to then be able to decide what to do with that building?
Yeah, absolutely. What you can do now with the Internet of Things, because there's wireless technology now, you can start to collate that data by retrofitting in the sensors and things like that. Again, exactly what's been mentioned from the previous question. It's assessing what data you need to enhance the energy performance of a building. So there is going to be some data there, even if it's just the bills, the energy bills, and understand where the biggest uses are. And part of that, Alex mentioned about the expert knowledge, putting that into the digital twin, if you like. If you can very easily start to assess the systems that are in the building, and start to build up that sort of view of what's happening in that building with the use of temporary sensors, with the use of wireless sensors, and start to build up that knowledge of the building. And then that data can then be used to make intelligent decisions about how that building can be improved.
Can I just jump in here? And
please do.
I'm going to slightly disagree with you here by the fact that your assertion here is that you have to have data to have a digital twin, and that's fundamentally incorrect. We build digital twins of systems that don't yet exist. That's the point of physics modeling. Physical modeling is that you can model something that either exists or doesn't exist without having a huge amount of data. And that really is the power of a digital twin, is that you don't need to be looking backwards all the time. You can look forward if you understand the system. If you know its current state, so be it with sensors, even without sensors, you can predict how it will perform in the future without having to look backwards. So I'd say that's, to somebody who's like looking at, say, an old building or an old piece of infrastructure, you don't need to worry about the fact it's not been sensored up for the last 30 years. It doesn't matter. You can still build a digital twin of something without any data if you really want to. and still be able to gain really valuable insight into how it will perform.
So, I mean, so Alex, how would you do that? I mean, if I've got a 6-story office building and it's sort of...
You've got a 6-story office building, so we would say, okay,
yeah.
the first thing always comes down to it doesn't matter whether you're doing this in construction or in aerospace and any engineering, it is what are your goals, what are your constraints, and what are your requirements? So my first question to you would be, what are you trying to model? What are you trying to achieve with your digital twin for your 6-story building?
Well, I mean, it's using a lot of energy and I want to make it more energy efficient.
Okay, so you want to reduce energy consumption. So we build a model. We build a model of how your 6-story building is using energy. We understand what are the sensitive parameters, what processes are the dominant ones that are using energy. And then from that, we can start to look at what are a range of technologies that can reduce that. We can then build models of those technologies, put that into our digital twin, predict how in the future your building will start behaving, then choose the best one. We can also understand how sensitive is it to us putting different technologies in or different settings in the technology. We can do optimization, do sensitivity analysis. We can work out costs, we can incorporate whatever you want. And you don't need to have any idea of how it performed a year, 5, 10 years ago. If we know the current state of your building, we can take that as a basis and go forward from that without having to feed lots of data and feed AIs and all these things that require huge amounts of compute. And as Neil was alluding to, huge amounts of energy to store all of this. It doesn't have to be like that. It doesn't have to all be looking backwards. You can just look forward using science, basically. It's maths, it's equations. It's the things that we use to design anyway, but actually using it to look forward from its current state and taking a more holistic approach to this.
And so, Catherine, how does that sound to you, that approach?
I was just about to say, so it depends on what you're talking about as data as well, though, because to understand the state of the building, the U values, for example, if we go really basics, to be able to model that is all data, and you have to establish all of that. And so while I agree with you in the modeling, and that's what we do when we're testing out design solutions, there is data that needs to go into that model to actually,
so if it doesn't exist, you calculate it. Why not?
Yeah, well, absolutely, but it's still data, even if it's not collated data is all I meant in terms of physically collated data. It's still data that you're producing and working out from the building. But yes, absolutely, I totally agree in terms of simulating simulating models of buildings to establish how different changes are going to affect the overall performance of the building. That's absolutely key to assessing how you can improve a building in the most optimum way.
Great, well, thanks. We're sort of, I'll just really jump in here. We're actually over our allotted time, but I think that just that discussion there shows how much further this debate's got to run and run and run. And, it's a really, really interesting topic, and I hope everybody enjoyed listening. If you want to hear it again, you can download it on demand. So all it really remains for me to say is thanks very much for our panelists for a really interesting discussion. Thanks very much.
Thank you.
Thank you very much.